What's up, everybody? Welcome back to another video. This is part 2 of our video series on exponents in Algebra 1. And we're going to add basically two new rules today. We're going to do a bunch more examples to expand your knowledge about exponents. And I've got a little hint here. Maybe you've seen this film. Maybe not. But yeah, anything to the zero power turns out is, I know what you're thinking, itself 0? No, it's actually 1. Anything to the 0 power is 1, which seems a little weird. So we're just going to do a bunch of little practice problems. We're going to talk about how we think about this and just how to use it in general, and then I'm going to convince you that it's true. Yeah. So anything to the 0 power is 1, so 4 to the 0, that's 1. How about 100 to the 0th power? That's 1. How about -4 in parentheses to the 0 power? Also 1. How about x to the 0? We think about that as 1. How about, how about 4x squared minus 9x plus 300 to the 0 power? It's 1 because all this junk is contained in the parentheses, and those parentheses are being raised to the 0 power. Okay. So we said 4 to the 0 is 1. We said -4 to the 0 with parentheses is 1. What about -4 with no parentheses? Methinks we have a problem here. Well, really not too bad. What this is it's just the opposite of 4 to the 0. That's how we read that. It would be logically equivalent to -1 times 4 to the 0. Well, 4 to the 0 is 1, so that's -1 times 1, which is -1. So that one's a little bit funky. How about 4x to the 0? Same thing. This 0 is not on the 4. The 4 is to the first power. It is only on the x. So in this case, it is going to be 4 times x to the 0 is 1, which is 4. You might be wondering, Mr. Schlegel, what about 0 to the 0? Well, it's, for the intents and purposes of this class, it is 1. Turns out if you take a limit, or as you are approaching 0 to the 0, it turns out that it's getting, or at least from the positive side, it turns out it's getting closer and closer to 1. So that's pretty exciting. Okay, but that's more advanced. Don't worry about it. For all intents and purposes of this class, anything to the 0 power is 1. Super. Let's go ahead and make sure you guys write that on your little cheat sheet for your math rules. Cheat sheet for math rules, and it's going to be on the middle left box. Fantastic. So that's our 4th rule for exponents. Now, you're probably saying, Schlegel, you told me this rule, we did some practice problems, you haven't convinced me that it's true. Well, here goes nothing. All right, let's take a look. I'm going to convince you that something to the 0 power is 1. Let's start with 3 to the 3rd. We're going to go down the line here. 3 to the 3rd is 3 times 3 times 3, which is 27. Okay, cool. How about 3 to the 2nd? Uh-oh, the number's dropping. 3 to the 2nd is 3 times 3, which is 9. 3 to the 1st is 3. So if you're noticing a pattern here, you'll notice that as I'm continuing down between these steps, I'm decreasing the power of 3 by 1. And it is logically equivalent to me dividing by 3 to get to that next step. 27 divided by 3 is 9. 9 divided by 3 is 3. That can be seen if you do 3 times 3 times 3 divided by 3. One pair of 3's cancels, and you're just left with 9. I'm going to sneeze. Maybe not. So what if we continue this process? What if we continue and we come down and it's, I'm going to do the same thing here. I have decreased the power by 1, which means I have divided by 3, so I'm going to divide by 3 again. And we end up with 3 divided by 3 is 1. Amazing. Amazing. 27. 9. We can go in the opposite direction. If you are going in the opposite direction, if you want to know what 3 to the 4th is, you take what 3 to the 3rd is and you multiply by 3, because we learned that you can, if two bases are the same and you're multiplying, we can add their exponents. So 3 to the 3rd times 3 to the 1st is 27 times 3, which is 81. Okay? So you can go up. If you're going this direction, you can think about timesing by 3 to get to the next number going up this way. So hopefully you're convinced. As you continue down, 3 divided by 3 is 1. Well, it turns out it doesn't stop there. The process continues. 3 to the minus 1, 3 to the minus 2, 3 to the minus 3. These are all possible. So I'm going to continue. What's 1 divided by 3? We're going to continue this process. 1 divided by 3 is 1/3. What? So, yeah, if you have something with a negative exponent, usually that means it's kind of a small number. I like to think of it as a smaller number. It's not always smaller, but most of the time it's smaller, and it doesn't necessarily mean negative number. So let's do that again. What if I want to get to 3 to the negative 2? We're going to divide by 3 again. All right, so that's 1/3 divided by 3. Okay, we learned that rule for fractions, right? Skip, change, flip, leave the first alone. Change division to multiplication, flip the fraction, multiply across the top, multiply across the bottom. We get 1/9. Okay, if you do the same thing again, you're going to get 1/27. Now you may notice a pattern. The pattern is, if you're starting at 1, this is kind of the center line, so to speak. And I go 1 this way, it's 3. If I go 1 this way in the negatives, it's 1/3. If I go 2 this way, it's 9. If I go 2 this way, it's 1/9. Okay, they're kind of like mirrored. So whatever 3 to the 2nd is, if I go 3 to the minus 2nd, it's the same number, but it's in the denominator, and we have a 1 in the numerator. If I go 3 this way, I have 27. If I go 3 this way, I have 1/27. That process continues, right? 3 to the 4 is 81, so that means 3 to the minus 4 is 1/81. And you can go forever in both directions with this pattern. And it doesn't just work with 3s. It works with any number that you want. You could do 2s or 4s or, heck, whatever you want. 2 to the 0 is 1. 2 to the 1 is 2. So 2 to the minus 1 is 1/2. It's 1 over whatever you got for 2 to the 1st. 2 to the 2nd is 4. So 2 to the minus 2 is 1 over that number. It's 1/4. And again, we can continue forever in both directions. Pretty exciting. Pretty exciting. Gotta love it. All right, let's go ahead and move right along here. All right, so here's rule number 5 for the unit. Rule number 5, and this is kind of, in a way, I've written it in a way that's not super mathematical, I realize, but it's how I remember. It's a good way to get us working. This is the actual law right here. Any number with a negative exponent is on the wrong side of the fraction. I should put that in quotes. So basically, it's grumpy, right? It's grumpy in the numerator. When I say wrong side, I mean numerator and denominator. It's grumpy in the numerator. It wants to be in the denominator. It's positive down here, negative up here. Similarly, if you have a fraction and you have a base that's in the denominator and it's not happy, it's negative in the denominator, you move it up to the numerator, it becomes positive. It's all happy, all good to go. Okay, so write this in the middle block of your 9x9 exponent rule sheet. We're going to do a bunch of examples, so strap yourselves in. Here we go. In green, this is what I mean. So first of all, we go to each base in the numerator and each base in the denominator, and we're going to apply this rule. Anything with a negative exponent should be moved. Okay? W to the negative 3. W to the minus 3rd. Okay? That is negative, which means it is on the wrong side of the fraction, so I'm going to move it to the bottom. The act of moving it to the bottom makes that exponent positive. X to the 4th in the top. Y to the 10th in the top. Move that to the bottom. Or y to the minus 10. It is negative. It's not happy where it's at. We're going to move it to the bottom. We're going to make that positive. Now we're done. We've done all the ones in the top, so we come down to the bottom. A to the 3rd. It's positive, so it stays right where it's at. A to the 3rd remains in the bottom. B to the negative 7th power it's negative, so which means it needs to be moved. So you're going to say B, put the 7 in the top, and now this is simplified. If you wanted to alphabetize the numerator and the denominator, that is a common practice in the math world. I think a comes before w. Let's do that. A to the third, w to the third, and y to the 10th. Great. We are cruising right along. Let's do some more. Feel free to pause the video and give this one a try if you want. I'm going to go over it momentarily. Man. Okay, what are my bases? I have 1, 2, 3, 4 things. Okay, starting with the 3. This is 3 to the negative second power. That needs to move. It is not on the correct side, so 3 to the second power is going to come down to the bottom. X to the 9th is happy where it's at. Y to the 4th is positive. It's happy where it's at. W to the minus 2, well, it's not very happy, so we're going to bring it up to the top. It's perfectly possible, it is definitely possible, for all things to end up in the top, or all things to end up in the bottom. If that ever does happen, you just leave a 1 and on whatever side that you need to, just like we did here. Like we moved 3 to the bottom, we left a 1 in the numerator. Same process. Okay, but coming on over here, w to the 2nd, x to the 9th, y to the 4th, and in the bottom we have 3 squared, which is 9. So to make sure you are all simplified and happy, you want to make sure that all numbers are, one of the things you want to do is make sure all numbers have been evaluated. So 3 to the 2nd needs to be 9 for it to be in simplest form. So this is a happy answer, everything alphabetized, and all numbers simplified. Okay, I'm going to take a look at, this is kind of like a flash, bunch of little small problems and kind of talk about the distinctions between these. So 10 to the negative second power, there is no fraction, right? There's no numerator and denominator. Well, there is, we're just not writing it. We can put any number over 1, like that. So 10 to the negative second power is the same as 10 to the negative second power divided by 1. It doesn't change anything. So that means I can move 10 to the negative second to the bottom, and I'm going to leave a 1 in its place. Okay, and so that is 1 over 100. Okay, over here, this is very similar. Since in parentheses is negative, I'm going to move in parentheses the negative 10, negative included, and I'm going to leave a 1 in its place. This is also 1 over 100. And then the last one, this negative 2 is only on the 10 and is not necessarily included on that minus sign. So you can move it if you want. It doesn't actually make a difference. I'm not going to. I'm going to leave a negative 1 in the top. I'm going to move positive 10 to the bottom and leave it to the second power, which will leave us negative 1 over 100. Okay, a common mistake that I get from students, I'm just kind of trying to cover all the common mistakes that I see, is I teach you this rule where if it has a negative exponent, then it needs to move to the opposite side of the fraction. And what people inevitably end up doing is they end up moving negative numbers. Negative numbers don't necessarily move to the bottom and become positive, just numbers with negative exponents. I'm going to do this problem in 2 different ways. Okay, the first way that I'm going to do it is I'm going to leave this negative 4 in the numerator, and this is to the first power, so it's got a positive exponent, it's staying in the top. And this second one, I'm going to move down to the denominator, and I'm going to change the power to 4. Okay, so now what we're going to do is, we know this is negative 4 over 4 times 4 times 4 times 4, like this. Okay, so a pair of 4s is going to cancel here, and what we'll end up with is negative 1 over 4 times 4 times 4, which is 4 to the third, which is 64. So negative 1 over 64 is our answer. Okay, and then coming down here, oh, sorry, we're not going to do this one yet. We're going to do way number 2. So this is way 1. Way number 2, how do we do this? Well, the other way that you can think about this is we can apply rule number 1 from from our first lesson. That said, if two numbers have the same base, we can add their exponents. So this is going to be negative, and then we can do 4 to the 1 plus negative 4. Well, 1 plus negative 4 is negative 3. That's negative 4 to the negative 3, and now this is just like this problem right here. We're going to leave a negative 1 in the top. We'll bring 4 to the third down, make it positive when we do that, and we still end up with 1 over 64. Second way to get that answer. Okay, great. The other common mistake that I see people making is they look at this example and they're thinking that you're doing the reciprocal. You're not really doing the reciprocal. You aren't doing the reciprocal when you have a fraction. Like we didn't bring these things up, right? In this case, 3 is to the first power. So what we do is we leave the 3 in this case in the top. So 3 stays in the top, and x to the 6th moves to the top with it. Okay, and we're going to, if everything from one side is gone or has moved, we leave a 1 in its place, so we would just write this as 3x to the 6th. You're not flipping the fraction, you're not taking the reciprocal. The 3 doesn't end up on bottom. It has a positive exponent, so it remains in the top, and we don't have to write the bottom of the fraction. So you can just leave it as 3x to the 6th. So it's just a 1. All right, same thing here. This one is similar, but slightly different. The 3 is in the bottom. It's got an exponent of 1, so it's going to remain in the bottom. So we'll leave a 1 in the top. The 6 is going to move, and you'll have 3 times 6 squared, making it positive when we move it. Make sure you are evaluating these. If you do have these numbers and you can't evaluate, then you're going to do 3 times 36, which is 1 over, and then 36 times 3 is 108. So 1 over 108 is our answer there. All right, so when you have a question that's like an ugly fraction like this, what you want to do is you want to, first, if you have like two numbers in the top and bottom, you want to make sure that it's simplified. So if you were to simplify the fraction 9 over 3, that would simplify to 3 over 1. So that's step 1. Okay, now we're multiplying these numbers by everything that's left. The next thing you want to do is you want to try and simplify all of the bases that are in the numerator, and then all of the bases that are in the denominator. That is one way to approach it. There are many ways to approach these problems. This is one way to tackle these. So there's only one x, so that's going to come along for the ride. There's only one y, so that'll be to the 4th. But there are two w's, and this is actually w to the 1st, so we can do w to the minus 3 plus w to the 1st. Fantastic. In the bottom there, there's our 9/3 simplified to 3 over 1, so we don't have to worry about the 3. We have two x's, x to the minus 2 plus x to the minus 5. And we have a single w to the 5th and t to the 1st. Great. So let's keep on going. We're going to simplify this one step further, so that's going to be 3. 1 times anything is itself, so I actually don't need to write the 1 there. So that'll be x to the 3rd, y to the 4th, w to the minus 2, and then in the bottom, you'll have x to the negative 7th, you will have w to the 5th, and t to the 1st. Okay, now that the top is simplified and the bottom is simplified, we can go and move terms to the side that they are supposed to be on. Come on, Slagle. All right, so this will be 3 here. And then we have x to the 3rd is positive, so it'll stay where it's at. Y to the 4th is positive, so it'll stay where it's at. W to the 2nd is going to move to the bottom. Coming down to the bottom, x to the minus 7 is going to move up to the top and become positive. W to the 5th is going to stay where it's at because it's positive, because the exponent is positive. And t will also stay down there. Okay, and we're almost done. The last step here is we have our 3, and we have two x's in the top. X to the 3rd times x to the 7th is going to be x to the 10th, y to the 4th. And then in the bottom will be w to the 7th times t. Yahoo! All variables, we know this is simplified because the fraction out front is simplified. all variables are only written once, and there are no negative exponents in our answer. All right, you guys can try this one. Go ahead and pause the video if you'd like to give it a shot. If not, you can unpause and work along with me. So again, let's repeat that. Are there any fractions that need simplifying? Nope. Is the top simplified? Actually, not completely. Every variable only appears once, but z to the 0, this z to the 0 is actually just 1. So it's not z to the first, it's just 1. So this whole thing can be replaced with a 1. So that's x to the minus 5, y to the minus 3 times 1. And then the bottom we have x to the second, w to the third. Okay, now we get to go through and move all the variables we need to. So we'll start in the top. X to the minus 5 is negative, so it's going to go down to the bottom. Y to the minus 3, go into the bottom, and x to the second stays where it's at, and w to the third stays where it's at. So what's left in the numerator if everything's moved down? It's always a 1, or denominator. Okay, and then lastly in the bottom we have two x's, so that'll be in alphabetical order. W to the third, x to the 2 plus 5 is 7, and y to the third. Bingo. All right, what do we got next here? Oh yeah, I got a couple more. These are kind of like ones you received on the last one, so I'm going to do 2 more of these just for kicks and giggles. And it goes back to this problem here. What's 2 times 3 squared? Okay, you get a lot. The 2 answers that you commonly get are 36 and 18. Well, which one is it? Well, if you answered 36, you multiplied first and then did the exponent. If you answered 18, you did the exponent first and then you multiplied by 2. That's what we're supposed to do because of our order of operations that we're supposed to follow, right? We're supposed to follow this order of operations, so you do the exponents first, which is 2 times 9, which is 18, right? So over here, we have exponents that can be evaluated or simplified. Like we have this exponent that we need to deal with, which we can make simpler, and then we'll be able to multiply the result when we're done. So that's what we're going to do. We're going to deal with this too. So we're going to apply rule 3 here. There are 3 bases inside the parentheses that we're going to raise to the, so we have negative 2, x to the third, y to the minus 4th. Don't move anything yet. Let's try and simplify this expression first. 3 squared, so you're going to raise all of these things to the second power, times x to the minus 5 squared times y to the 6th squared. All right, so coming down, we're going to get this thing simplified. Y to the minus 4th times 9. That's going to be x to the negative 5 times 2, and y to the 6 times 2. So what we end up with here is negative 2 times 9, and then we're going to have x to the, let's think about this, third, x to the negative 10th, y to the minus 4th, and y to the 12th. So now what we do to simplify this when we're done, whoa, we're running out of space. Now what we do is we're going to multiply on the front, so you get negative 18, then you're going to do x to the 3 plus negative 10, which is negative 7. And then you'll have y to the negative 4 plus 12, which is y to the 8th. We're still not simplified because we have this negative exponent, so that needs to move down the denominator of the fraction, so we'll put this over 1, and you end up with negative 18y to the 8th, x to the 7th. Cool. Okay, you go ahead and try this one on your own. This is our last question. Hope you've enjoyed the video, and then unpause it when you're ready to check your answer. All right, let's go ahead and get started. So we end up with here x squared. We got to evaluate the exponent first. We're going to raise that, each of the things in here, to the third power. So that's going to be x squared times 2 to the minus 3 times y to the minus 3 times x to the positive 12 when we multiply. Okay, adding, we're going to get 2 to the minus 3 Well, let's move stuff around first. You can combine here, but it doesn't actually make a difference. So we're going to move x to the second stays in the top, x to the 12th stays in the top, 2 to the third moves to the bottom, y to the third moves to the bottom. So you end up with, when you're done, x to the 14th over 2 times 2 times 2, which is 8, times y to the third. Great, that's it. Thanks for watching. Your assignment's on My Open Math. Hope you liked the video. See you next time.